Good morning students. We have already studied about calculus. Now we discuss about the applications of vector calculus. Vector calculus plays an important role in differential geometry and in the study of partial differential equations. It is used extensively in physics and engineering, especially in the description of electromagnetic fields, gravitational fields and fluid flow. So planes are given a vector to travel and they use the SP to determine how far they need to go before turning or landing. So now one by one, tell me the application of vector calculus.
Vector calculus has numerous applications across various fields, such as physics, engineering, computer graphics. First, physics. Vector calculus is fundamental in describing physical phenomena. For example, in mechanics, vectors are used to represent forces, velocities, and acceleration, and calculus is applied to analyze motion and interaction between objects. In electromagnetism, vector calculus helps describe electric and magnetic field and their interactions through Maxwell's equation. 2. In engineering, vector calculus is essential in engineering for analyzing fields such as fluid dynamics, heat transfer, and structural mechanics. It's used to model and solve problems related to the flow of fluids, the distribution of temperature in materials, and the behavior of structures under various loads. 3. In computer graphics. In computer graphics, vector calculus is used extensively to model shapes, surfaces, and movements. Techniques such as 3D modeling, rendering, and animation rely on vector calculus to manipulate objects and simulate realistic behavior. And various other applications are also applied to vector calculus, such as in the field of economics and finance, geography and zoology. Let me give a small idea of it. In economics and finance, vector calculus can be applied in economics and finance to model optimization problems such as maximizing profit or minimizing risks. It also used in analyzing dynamic systems such as those found in macroeconomics or financial market. Geographical and geology. In geospatial analysis, vector calculus is used to analyze terrain, map elevation changes, and model geological processes. It helps in understanding phenomena like erosion patterns, tectonic movements, and seismic activities. Thank you.
Image processing used in image processing for edge detection, image registration, and segmentation. Economics applied in economics for modeling equilibrium conditions and optimizing resource allocation. Game development utilized in game development for physics simulations and collision detection. Chemical engineering used in chemical engineering for modeling fluid flow in reactors and transport phenomena. Environmental science applied in environmental science for modeling pollutant dispersion and groundwater flow. Mathematical biology utilized in mathematical biology for modeling population dynamics and biochemical reactions. Structural analysis used in structural analysis for analyzing stresses and deformations in buildings and bridges. Renewable energy applied in renewable energy system for optimizing wind turbine placement and solar panel orientation. Telecommunications utilized in telecommunications for analyzing signal propagation and antenna design. Urban planning used in urban planning for traffic flow modeling and infrastructure design.
Vector fields. Vector calculus is used to study vector fields, which represents quantities like velocity, force, and electromagnetic fields. Differentiation. It helps in differentiating vectors fields to understand how they change over space. Gradient. The gradient of a scalar field helps to determine the direction of steepest ascent and descent. Divergence measures the rate at which vector field diverges or converges to a point. It is useful in fluid dynamics and electromagnetism. Curl. It is the measure of rotation of a vector field around a point, and it is essential in fluid flow and electromagnetism. Line integrals can calculate the work done by a force along a path.
Vector calculus has numerous applications across various fields. Physics, used extensively in classic mechanisms, electromagnetism, fluid dynamics, and quantum mechanics. For instance, it is crucial for describing the motion of the particles and field, and analyzing electric and magnetic field and understanding the fluid flow. Second, engineering, widely applied in fields such as aerospace, civil, mechanical, and electrical engineering. Engineers use vector calculus to analyze stress and strain in materials, model fluid flow in pipes and channels, and design antennas and circuits. Third, computer graphics, essential for 3D rendering, simulation, fluid dynamics, and particle systems, and modeling light propagations. Vector calculus helps in determining surface normals, calculating light effects, and stimulating realistic motions. Economics and finance, used for optimization problems such as maximizing utilization functions and minimizing risk in protocols.
Medical imaging, used in MRI and CT scans for reconstructing three-dimensional images from two-dimensional data. Electric engineering, essential for analyzing circuits and anatomics and electromagnetic devices. Aeronautics, used in aerodynamics for analyzing airflows around aircraft and optimizing